Since we already put all 32 pieces on the board, it's natural to move on, to move the pieces. So we'll handle mouse events today. Let's get started. So we'll encounter the new concept of interface. Interface is something like an agreement or construct. So it's like to implement an interface means our class make a promise to do something. So implement mouse listener. So you see this mouse listener is in this path java.awt.event, and now immediately we see some errors here. But fortunately, Eclipse can add unimplemented method automatically for us. Click that. So now immediately all the errors are gone. That's because we added all the needed in interface method here. Mouse clicked, mouse pressed. So it means when we make some changes on the mouse, some of these methods will be called by the Java platform. For example, if we click the mouse, this method will be called, and passing in an object of mouse event. So we are interested in this one, mouse pressed. So as our first try, let's print out where our mouse is. So delete this line. We can do this point. Yeah, this point. Mouse tip equals, and inside this mouse event E, let's rename it to mouse event E because E sounds like exception. So me dot get point, yes, and let's simply print out this thing as well as O control space, yeah, mouse tip. Let's give it a try. Control Command S and run it. Let's bring up the console here, and here is our chessboard. Now click somewhere here. Oh, not yet. We still have another thing to do because we promised we can handle this interface, but we still need to do one more thing here. Add mouse listener. This is, so who will be the mouse listener? Ourselves. So this, now it should be okay. Run again. Now let's click here, close to the 0, 0. Yes, X is 5, closer. 3 and 5. Okay, that's going down. X is still small and Y is bigger. Let's go here. X is 58 and Y is here. Y is 6. So what about here? X should be big and oh, it should be close to 800 and 800. Let's see. Yes, it works. So now you have some feeling about the mouse listener and how it works. We can use this to control our mouse and make use of it to move our pieces. So we handle the mouse pressed. We still need to get mouse released, because when we drag and drop the piece, right, one of the pieces on the board, we need to press down and drag, then release. So this one is also important. Let's do the same thing here. So let's try, ME, let me name it ME. So now let's try, so better to put some helpful information here, like mouse pressed at, and here mouse released at. Let's give a try. Run it. See, we are trying to drag this top left rook. Okay, so click and drag down to here. You see, our mouse moved from this location to this location. Cool. You see, only Y increased a lot, and X remained almost the same value. Nice. Now let's create a handy helper method to convert our screen coordinates to our logical coordinate. For example, let's run it. So it means when we click in this area, we want to make sure we are handling the logical coordinates 0, 0. So here is when the screen coordinates is within this area, roughly this area, and we want to make sure we are handling logical coordinates 1, 0, here 1, 1. So the screen coordinates is about, you see, x is here, y is here, right? But the logical coordinates is 1, 1, 1, 2. The screen coordinates is x is from here to here, y is here, right? Roughly in this area. We'll use the square to check if our mouse is within this area. The algorithm is like private point. You will return a point x, y, 2, column and row. Yeah. So point, we use this name, return. The algorithm is neat. So this xy dot x minus orgx plus size divided by 2. And this xy dot y similarly minus that side and this expression is kind of neat. Yeah, think about that as an exercise. Why it works like that? With that, we can make use of this one in our mouse pressed. Now we don't need this one, mouse pressed, okay? Delete that. So we have mouse tip. We want to remember where we pressed the mouse, because at the moment when we release the mouse, that information is gone. So let's create a variable to remember it. Private point from colon. Oh, yeah, we can remember that. So now here from colon row equals xy 2 we can simply put this one here to save one line. Yeah, delete that. That's cool. Now let's go here. So we need to check if from that point is now, it means we never click the mouse. So we'll return, we'll do nothing, right? This has to happen first, right? Then we can release. So we have a start point and end point. Yeah. Now this we can name the 2. Let's delete that. The destination 2 colon row equals xy2. So this is an e dot get point, right? So that is the destination coordinate, logical coordinates. For example, we'll move from 0, 0 to 2, 0. So this is like the logical coordinates. Now we can check if board dot valid move. We need to make sure it's a valid move, right? So from column, yes. So from column dot x. Yeah, this is from column from row, right? Y. 2 column is this dot x and the 2 row. If that is valid move, we can make the move. So d dot move a piece. We can move the piece to so we can copy that. If it's a valid move, then we can simply move it, right? We can also print out the board to check. That's why SO, print out the board, BRD, and don't forget, we need to repaint our window. We draw the right, updated the game board. Now let's give it a try. Save and run. Let's try to move our red king. So click and drop. You see? It's like magic, right? It works like charm. So here also we can see the king was moved to here. So that's it for today. See you next time.